So we're going to start talking about putting our assembly together. I'm going to switch windows to show you the completed engine assembly here. And ultimately what we'd like to be able to do is actually put some animation by adding relationships to the different parts and applying a rotational motor to this flywheel portion. We can simulate the motor using this animation sequencer, and I'll put it at like 4x so it goes a little faster. We would like to be able to animate the motor so that the valve cam goes up and down. We can actually turn off the cylinder block so we can actually see the piston going up and down. We can turn off the steam chest right here. I'll go back and turn off that steam chest cover plate. Find it. There it is. So now you can see the valve and the piston. I'm sure the timing is not right, but it gives you an idea how the animation helps perform the function of analyzing the structure. In addition, there are some other functions that you can do, some ability to determine whether it is having some conflicts with other parts, but right now this one appears to be going the way it should. So initially what we want to do is start assembling this unit together. So I'm going to go back, I'll stop this, I'll escape out of it, and I'm going to switch my windows into a blank assembly. This is just an assembly model. Over here we have a parts library. You may need to go search out where your parts are, but we're going to start. The first part you put on is your part 1, which is your base, first part we drew. You can just either double click or drag and drop. I kind of like to drag and drop, and it gives me a little bit more opportunity. Our base plate is basically your anchor. This is a part that will not animate or move, so it should be the part that just is the foundation for your project. Now we look at the next two parts are both going to be part 2, and I can just drag and drop part 2 out here, and it is this post. You'll notice it comes up with this relationship module, and it starts with a flash fit. So if I want a flash fit from the bottom to this circle, you'll notice it pops it right into place. We can do the same thing part 2. I'll just drag and drop it. Yeah, sticks in the bottom. So again, we get a flash fit. These relationships have flash fit, mate, planar align, axial align, insert, parallel, connect, angled. So there's a lot of these that you can use. Most of them are up here on the top. Again, we just find the hole in the center and match it up to this hole, and it brings it up and places it right where it needs to be. Sometimes a little more difficult part might have multiple locations, so we'll go to part 3, which is our basically our bearing block. And again, we will create a flash fit in that I want this bottom plane to line up with this plane. And then my second relationship, and this is symmetrical, I want to find should be able to get that little hole in there. Not, I'll just change this to an axial align, and that way it'll just find the oh, I know why it's not working. I get it. Oh no, it's right. Okay. So I want this hole to line up with this hole, and then I want this hole to line up with this hole, and that spins it around. This is symmetrical, so it doesn't matter whether it's forward or backward. So there's my piece on the top. I do a fit view with a, before I put the crankshaft in, I'm going to put a bottom plate on here. Part 4 is a flywheel bottom support right here. and this fits on top of these two posts. If this hole and this hole, I'll bring it up in here, and I want to flash fit the bottom, to roll it around so I can get at the bottom, to the top of these pipes. Then I want to locate, I'll just take my axial align, and I want to locate this hole to this hole, and then I want to line this hole with this hole. So you can look down, you can see my holes are perfectly aligned. If I look underneath, you can see that the threaded holes for the bottom are all lined up also. So it does a pretty good job of locating what you need to. So probably another one of the more difficult parts is the cylinder block, which is right here, part number 5. You just bring it up, place it up here in the air. And it's important to recognize that the valve holes, these holes here, need to be facing this way. So the first thing I'll do is line up my bottom faces. This face needs to line up with this face. Okay? Now we need to spin it, so that means I'm going to go to an axial alignment tool, and if I line up my bolt holes correctly, so this bolt hole would end up being lined up with this bolt hole. That means that this bolt hole, come on, I'll use another one, doesn't want to grab it, means that this bolt hole will line up with this bolt hole. Perfect. Generally takes 3 relationships to fully constrain an object. Sometimes you don't want them fully constrained, sometimes you want them to be able to just stay put and not move. So I've put on basically the 5 materials right now that will not move. As we put on things like the crankshaft, and let me just put the crankshaft in right now and show you the start. There's part 9. I got a bunch of them here. I'll just bring that in. Part 9, we're going to flash fit with the let's see, I probably just want to use an axial alignment here, and I'm going to line up this line with this line, and flip it. I did. And I'll just I just take this and select it now, grab this arrow, I'll just pull it forward, and I'll pull it approximately to this location. So this will eventually move anyway, but you can see that this cam needs to be able to roll around, and actually is what pushes the piston up and down. So it's not in the right position, but I will show you that if I apply a motor, a rotational motor, to this object right here, and click again to show which way it's going to spin. It's going to spin in that direction, 120 degrees per second, and finish. It creates a motor. So if I actually look at that, it creates a motor 1. I'll just say OK, and we'll run this at 2 times the speed. You can see that that will spin around. This is what drives all of the other parts, so we actually can rotate it while it's spinning. So as that's going around, when we put our cams on, we're going to give those axial relationships and planar relationships so that they will operate the motor. So this runs for a few frames. You can save it as an AVI or some type of, if I want to save that animation, not sure what comes up, but you can change camera paths, save as a movie, gives you the opportunity to save it as an AVI film, so you can embed that into a presentation. But it's actually kind of a cool little tool. So also it's a little bit frustrating, so it takes a little bit of practice to get used to moving things around. But what you're going to use is your movement tools and also your relationship tools to make things fit together and relate in such a way that it operates like this completed assembly with all of the parts moving in unison. No, that's not moving. Maybe it's just loading up. No. Simulate motor. Animation 1. Nope, there it goes. So we can see our valves going up and down with our piston. We can turn things on and off to be able to see certain aspects of it. Or we can just watch the whole motor. And again, you can kind of spin it around while it's in motion to save it however you like. And that's it. So we're going to be, as we do more of our model parts, we're going to start assembling these things. Part of your final project will be to put these together. So as we get all of our parts together, all of our animation done, our assembly complete, then we're going to take it in, explode it, and complete our portfolio for the final project.